So this video is a follow-on from the last solving inequalities video, and in this video we have a case where the questions are slightly more difficult. Like in this one here, we have two inequalities in the same equation. In the last one, it was just one. Now, there's two different ways you can do these questions. Personally, I prefer to do the second way, but I'll show the first way first just to see what it is. So you see here, you have minus 9 is less than 3 minus 4x, which is less than or equal to 1. And x is an element of R again, so that will come up later on when you have to plot your solutions. So what you could do, okay, so this is going to be method 1, is you could split up the equation. So what that means is I'm going to take this section first. So if I rewrite that, it becomes minus 9 is less than 3 minus 4x. Now it's similar to the last videos, we just solve as normal. Minus 9 is here. The minus 4 is negative on that side, and usually we have the x's on the left. So I'll bring the x across to make it a bit easier. And it becomes positive, 4x. That 9 is going to go across to the right hand side, and it becomes the opposite, so that becomes plus 9. So 3 doesn't move, so that's okay. 9 comes across, plus 9. So we have 4x is less than 12. X is less than 3. Okay, so that's one section of it. Now the second section is if I take this side of the equation, and that becomes 3 minus 4x is less than or equal to 1. Again, try to solve that as normal. The 3 I'm going to bring across, so minus 4x is here on its own, less than or equal to 1. 3 comes across and becomes minus 3. So now we have minus 4x is less than or equal to minus 2. Now we have minus 4x. We don't want minus 4x, we want positive. So if you change signs, that means you have to flip the inequality in the middle. So minus 4x becomes plus 4x. That minus 2 will become plus 2, but this inequality changes sides. So instead of being less than or equal to, it becomes greater than or equal to. So now we solve this again as normal. 4x is greater than or equal to 2. We don't want 4x, we want 1x. So x is less than or equal to 2 divided by 4. X is greater than or equal to a half. Now, the next section, we need to put these two together. Okay, now how can we make that work where they're in the one combination, similar to what it had up here? We know that x is greater than or equal to a half, so that's the same as writing a half is less than or equal to x. So if a half is the smallest. Now on this one we can see that x is smaller than 3. So by combining the two of these together, we know that a half is less than or equal to x, but we also know that x is less than 3. So that's our answer at the end. Now to plot this solution on our number line, we need to use these two numbers. So it's a half and it is 3. So what I'm going to do is put a circle around where a half would be, and put a circle around where 3 is. Okay, so there are two bounds. Now if you look back to the question at the top, it says x is an element of R, so that means it's all the bits in the middle. So you shade in like we did in the last video. Now what do we do with these two circles? Now it's very important when you look back at what the inequality says. That has less than or equal to, so a half is less than or equal to x. So a half can actually be an answer. Now because that line is there, that line is very important, because that's there, I can shade in the 2, or sorry, the half. There's no line with this, so x is strictly less than 3. It cannot be 3 at all, so this stays empty, this circle stays empty. So now this is my full solution for the above equation. So now we know what the answer is from above. It's a half is less than or equal to x less than 3, and that's our solution set. I'm now going to show you how you do method 2, which is the method I personally prefer. Instead of splitting up the inequality like I did up here, you can actually keep the inequality together. But what you do is try to get the x in the middle and get everything else away. Now the first thing that I'm going to try and move is the 3. Because again, we're trying to leave the x there, so that comes out. The 3, we know from above, came across and became... Oh, sorry, I actually went the other way. The 3 gets to the same side as the 9, so the 3 here becomes the same side as the 9. It goes this way. So we have minus 9. It's a positive 3, so when it crosses over, it becomes minus 3. Less than, minus 4x is now on its own in the middle, greater than or equal to. Up here, the 3 also joined the 1. So on this part down the end, this 3 also goes to the other side. So it becomes 1 minus 3. Whatever you do in the middle has to happen to both sides. So it kind of goes up and across to the left, and it goes across to the right, as shown below. If I clean this up a small bit, we get minus 12 is less than minus 4x, which is less than or equal to minus 2. Very similar to what we had above. Very, very similar numbers. But there's a slight change. We now have minus 4x in the middle. We don't want minus 4x. We want positive 4x. So if we change the sign first, if this is going to become from a minus to a plus, that means this has to change and this has to change. The minus 12 becomes a positive and the minus 2 becomes a positive. 12, 4x and 2. But as I've pointed out in the last video, when you change signs, you have to flip the inequality. So this less than becomes a greater than, and this less than or equal to becomes a greater than or equal to. Okay, so now the next little step I'm going to do is just write the whole thing backwards. If 12 is bigger than 4x, which is bigger than or equal to 2, then I can write that in total reverse and say, well, 2 is less than or equal to 4x, which is less than 12. So all I've done is just rewritten this line backwards to get it used to what we're used to looking like with this part here. The less than and less than or equal to. We're now almost done. 4x is in the middle. We need to try to get rid of the 4, so we divide to the left and to the right. So you get 2 over 4 less than or equal to x less than 12 over 4, and that becomes 2 over 4 gives us 1 over 2 less than or equal to x. 12 over 4 equals 3, which is the same solution that we had above, which will give us the same solution set. Now in this second example, we have a little more complicated looking question. So it says find the solution set A and all of this rigmarole. Now it looks very complicated, but it's actually not. It's just a different way of writing what we've already done. So it means x such that 7 is less than or equal to 10 minus 3x. Now if we take away that part and that part, they look exactly the same as what we had already. It's just a fancy way of writing this. That just means that x is in here somewhere. So we have to try and solve that. The same with this section. And again, the most important bit at the end, x is an element of R, the real numbers, x is an element of R, again the real number, so it's the shading part of the question. And the final bit at the end, find the set A intersection B and plot your solution. Now we'll worry about that in a second. So first things first, we do set A and see what happens. Just rewrite this bit in the middle. 7 is less than or equal to 10 minus 3x. Simple enough. I'll bring the 3 minus 3x to the left and bring the 7 to the right to see what we get. So 3x has become positive, less than or equal to 10. 7 comes across and becomes minus 7. 3x is less than or equal to 3. X is less than or equal to 1. Nice handy answer to start with. Now the second one is going to be for set B. So again, this bit at the front doesn't matter, it's just a fancy way of writing what we've done already. So I'll just rewrite the whole inequality. 2 is less than 4 over 3 minus 2x. Again, the fraction is causing the complication, so we have to try to get rid of that first. To get rid of a fraction over 3, we multiply everything by 3. So I'll write it in this colour. So we would get 6 is greater than or equal, or sorry, just greater than 4 minus 3 by 2x is 6x. Now we have an easy one again, similar to what this line was. Bring this negative 6x to the left to make it become positive. So 6x is greater than or equal to, 4 stays where it is, that's okay. 6 comes across and becomes a minus. So we now have 6x is greater than minus 2. Now I'm going to be dividing by a positive 6, so it doesn't need to change signs. X is greater than minus 2 over 6. X is greater than minus 1/3. Now there are two answers that we're going to try and blend in together. Now I can rewrite this so that the x will be in the middle of these two inequalities. Minus 1/3 is less than x. But we also know that x is less than or equal to minus 1. So less than or equal to, or sorry, less than or equal to positive 1. So I can rewrite that now. So now that now is our intersection of A and B. That's where they meet. For this solution set, 1 is every single answer. Sorry, x is every single answer less than 1. Including 1. 1 is counted as well. For this solution set, x is greater than every single number that is bigger than minus 1/3. But when you use the intersection, you combine the two parts together. So it has to be less than 1, less than or equal to 1, but it has to be greater than minus 1/3. And that's what gives us this solution at the end. So I'm just going to, in the next little section, I'm just going to plot this and I'll show what it means. So I've now got my number line drawn out. I'm going to mark the two boundary points. So minus 1/3 is here. And 1 is this one. Then we go back to the inequality, the important parts. X is greater than minus 1/3. It cannot be equal to, so we leave this circle empty. Go to the right hand side. X is less than or equal to 1. Because it's equal to this little line that was important, that means you can colour this section in. So the 1 is included. And when we go all the way back to the start, in both cases, x is an element of R. X is a real number. So that means you can shade in the answers in between. And that is our solution set for solution set A intersection B.